All right, so we have here the AutoCAD Mechanical software, and just kind of as a preface here, a lot of people use AutoCAD Mechanical, but they don't necessarily realize that they're not potentially using all of the full tool set that is available within the AutoCAD Mechanical tool set. And so what I really want to do here is just kind of go through some of the process regarding can you guys hear me? I got a note here that's saying that there's no sound. Is there audio?
I'm okay. Yes, they can hear you. I'm seeing that now.
Okay, good.
Mm-hmm.
Sorry, I got a note that there wasn't any audio, so I wanted to make sure everyone could hear me. So as I was saying, AutoCAD Mechanical does have a very large number of tools defined within it to really just accelerate and deliver those very specific things that mechanical designers need. And so the first thing that I want to take a look at is just generating a file from scratch using some of the drawing tools that have been added to the mechanical tool set. So first thing I want to do is start up a new mechanical file. And in this case, I am going to grab my AM ISO. And obviously the big thing with template files is it's doing things like setting up our units as well as our overall screen size, but it's also doing some things in the background. So I'm going to jump under the hood for just a moment. And inside of the options, there are several additional controls that have been added specifically for AutoCAD Mechanical. The first and big one is the standards. And the idea behind this is all of our definitions for specialized objects. So things like when I create a detail or when I create dimensions, how do they look, act, and feel within the AutoCAD Mechanical realm? And these are above and beyond any of these object styles that are already in the AutoCAD Core toolset. So, you know, I could potentially go in and change my dimension styles using the AutoCAD Core tools, but this object here has within it which style it's going to use, different representations for specific objects, different placement options, and so on. Additionally, things like when I use AM structure, which I'll jump into a little bit later, how that structural process works, when I create working drawings as far as my layouts are concerned, what types of layers do I use? When I go into my content library, we have a full content fastener and shaft part library accessible to us. And again, all of those objects are defined, but we want to make sure that we specify where those files are. We also have some things for shaft generation, calculators, as well as just some general preferences for AutoCAD Mechanical. And as far as just the skimming the surface of the software, I'm not going to delve into these yet, but just know that when you start using the AutoCAD Mechanical tool set, it's definitely important you get into options and make sure you set up these AM options. And as you saw when I opened the dialog box, they are a little bit buried. So make sure you're doing that. So back over to our file here. The first thing that I want to do is just draw essentially just a part file that we're going to use in one of the documents I already have open. In my case, I want to draw a rectangle, and within the AutoCAD Core tool set, we have just a couple of options for drawing rectangles, and you'll see in here that we have a number of options available as opposed to that. So in my case, I want a center point option, and then just define the overall base size. And as I do that, we'll get to see that visualization of that model show up. So in this case, I can develop that. Let's just give this a quick rotate. That's not the right size. Let me delete that and start over. Rectangle centered. So 45, 120. There we go. So now that I have that in place, I want to draw things like positioning specific center lines on this object. So I'm going to use my construction line tool set, and inside of AutoCAD Core, we have the X-line command, and it has the ability to draw, you know, a horizontal or vertical and any angle that we define. However, in AutoCAD Mechanical, we can do a whole slew of different methodologies to create those construction line objects. So the first thing that I want to do is just the parallel with half distance. And the idea behind this is it gives me the ability to just specify an edge and then the overall height of a part, and it will calculate and draw in parallel and half the distance. So again, in that case, just 2 picks to generate that X line within the space. I could repeat that process as many times as I want, selecting new edges, defining new locations. In this case, I'm going to move this one up just 10 units on the model. So I can also use this tool similar to the old-fashioned way, as far as like more like an AutoCAD core. I just choose the horizontal and then specify the overall distance I have to travel, and it will create those lines as well. Now, the big thing you'll probably notice in here is that I don't have to do anything as far as changing my layer definitions. So in this case, as I drew this object, it drew it on the active layer. However, my construction lines drew themselves on my construction line layer, and that's all controlled by, again, those options. In there, we have our layer preferences definition defined. So when I create an object of a specific type, it knows where to put it within the system, saving me a bunch of hassle, changing my, constantly changing what layer I'm drawing on. So the next thing that I want to do is define just a quick center line on this part. We have a specific center line drawing tool. And again, the idea behind this is that I don't want to have to think about how far I need to offset. I don't want to have to change layers or line types or any of that stuff. I just tell it what I need and define it. Now, one of the other really cool objects that I really like is the symmetry controller. So in my case, I did create both of these symmetry lines. However, I technically don't need this one. And the reason for it is that I'm going to tell it that I want to draw symmetrical lines. I'll specify my center line object. I can then specify where I want the first line to go, and it will draw both lines across that mirror line. So again, just saving myself a little bit of hassle trying to generate those geometries. The next thing that I want to do here is I have a hole, or a side view of a hole that I want to place in here. And, usually I would have to go grab my machinist handbook and grab the, browse down to the hole definition size and spec out, try to find the specification. In my case, I'm working in ISO, so I need to make sure I have the right metric data. I don't want to do all that. That's a lot of work. So instead, what I'm going to do is I'll go over to my content tab, and on the content tab, we can see in here that there is a ton of generators available. And in this case, I'm just creating a simple hole. It is a counterbore, so I'll choose that option. And as I go into the Counterbore Library, we can see in here that we have various standards accessible. And in my case, I'm just going to scroll down to the ISO counterbores, and then I'm just going to tell it what view orientation I need. In this case, a front orientation. From here, I just need to specify what type of fastener I want. And then I get the option of defining, what orientation, if I were going to be inserting the fasteners in here, what type of orientation it would place them. This becomes more relevant when you get into more complex component shapes, but for a fastener, it really is not that big of a deal. From here, I'll specify my hole definition. And the last piece of this screw connection tool is I do have the ability to turn on and off various pieces or components within the stack. Now, in my case, I don't really care about, this fastener component, so I'm not going to tell it to include it. Okay. From here, the last thing I need to do is make sure I have the right metric size, hit next, and then just define the position of it. As I do that, it specifies where objects are located. If I had a gap definition in here, I could spec it out. In my case, I don't need to worry about that. All I have to do is hit finish here, and it generates the geometry. Now, there is a couple things that I could do to this object, and you can see there that it is a specialized component. It is a content library item. So if I want to edit this, I just need to go into the AM Power Edit mode, and to do that, I just right-click and choose Edit. And you can see in here the editing tools in the right-click menu are a little bit different. So we have in here the Edit mode, AM Power Erase, which would actually remove specific, AutoCAD mechanical objects. This becomes much more relevant in the next phase of the process, where it will actually remove objects from the structure of a design. AM Copy I'll show in a minute, but it does very, very powerful stuff here. The Power Dimensioning tool, this is one that's a little bit more antiquated. AutoCAD has been going through a lot of strides to make the standard AutoCAD core dimensioning tool function like the power dimension tool within our space here. So this is going to function very similar to what you're used to inside of AutoCAD if you're on, say, 2018 or 2019 AutoCAD core. But again, specialized tools for specific things. In my case, I want to get into the edit mode. I can select this, and as I do that, it essentially brings me back into the screw connection mode where I can do things like define specifications for the data. And the last piece of this is if I wanted to, I could tell this hole to be hidden since it is buried within the component. And as I do that, it will automatically adjust and change the line types and the layering of those objects as necessary. So in this case, I do have another one of these holes that I need on the bottom side. I'm just going to start my AM copy tool, select the original object, and then just specify a new insertion point. Now, the key and important aspect of this is that not only I can not only place this, but I can also redefine its orientation and its length as necessary. In this case, they're exactly the same, so I just choose the two endpoints and it generates the geometry. So at this point, I've got my part pretty much finished. I do have some construction lines on this object still that I don't necessarily need anymore. So I'm going to go over to my Home tab, and I'm just going to tell it to delete them all. We have a simple button for that where it erases all the construction lines. Now, with that in mind, there are some other tools that we can do in here. For example, if I have a zone that I've created or a specific area that I've created, I can tell the system to fill that zone in or a trace contour. So the idea behind this is like, say, for example, I'm trying to create the front profile for this side view. The first thing I could do is generate my projection symbol and then define where it's located. In this case, we'll position this off of that corner. We'll just take this straight over like so. We'll take it to there. I'm trying to think here. I want that to be touching a corner, but I don't want it to be in the way. It doesn't really matter where exactly it is and its alignment, right? We can always use it for any means necessary. But if you've never used one of these before, the general idea is that if I wanted to create the third view based on a set of component views, all I need to do is extend these lines out until they touch the orthographic projection line. I can then extend them upward, and it allows me to turn the view, right? This is usually generated for creating the third view of a model. But the other thing that I can do in here, I've got a construction tool set. And the idea behind this is that I can specify things like create a circle to end, to match the end of a shaft. So the idea here is that I can define the center line starting point and then define the center line ending point. I want to say it's that. Nope, that was the wrong position. This is one I'm not used very much. Quit it. I need tangent. Not that tangent. I need this one. Yeah, so select my center line. Select the contour point, and it will generate the, I didn't place it. I had the right geometry, I just missed this step. So bear with me a moment here. Select my center line, define the point, define its position. And so now I've got that defined. Again, I could repeat the process. So define the point, and then come over and place that centered. And in this case, that's defining the center position of those objects. I've got one more here that I can then position as well, and then I can accept that. So now in this case, I've got, essentially things like this is my center line, that's my internal edge, that's my external edge. And what that trace contour does is I can select that and then select locations or objects inside the zone, and it will in turn fill them in. Obviously, I can also grab these elements. They're nothing special. They're not, unique object types by any means. So all I would have to do in this case is just move them to the correct layering in order to convert them to complete objects or real objects inside of the space. Similarly, I've got my center marking controls. I have a whole set of them that I can define in here as necessary. And the idea here with like the center line circle or cross on full circle is, in this case, I have maybe 6 of these holes around that pattern. I could easily just select those and define them. And The idea behind these tools, more than anything else, is they're really just automated tools for generation of geometry, right? We're trying to save ourselves a lot of those, extraneous steps like going out to a book to reference the dimension sizes. We're looking at, how do I streamline the creation of a view? So at this point, I've got this part created. I'm going to go ahead and save this part. And then from here, what I want to do is I need to get in and do a little bit of creation of the structure of the data. And so the first thing that I want to do here is generate some BOM data. And to do that, I first want to create a part reference. In this case, I'll select by geometry. And then I can define what this is. So this is our hub. We can give it a description, what standard it's part of, what it's made out of, what unit of measure it's using, in this case, millimeters. If I double click into there, why is it not letting me type? And then also what its unit of measure is. In some scenarios, I may have multiple components stacked on top of each other, so I could increase the part referencing data. And then in this case, I'll hit OK. And as I do that, it creates this little BOM marker, and I'm just going to move this to a different location. We'll just get that kind of close to the center there. It doesn't really matter where it is. The actual marker itself goes on its own layer that I could turn off prior to generating a print, for example. So the next thing that I want to do, now that I have that BOM marker in place, is I'm actually going to switch modes inside of AutoCAD Mechanical. And right now we're in kind of the AutoCAD Mechanical standard environment. But what I want to do is I want to get into the structure environment. So in this case, I'm just going to switch to structure. And it's not going to change a whole lot, but it is going to add a couple of additional tools to the scene. And the first thing it's going to do is add the structure catalog. It's also going to add the mechanical browser on the left-hand side here. And then what I want to do in this case is I want to create a hub view definition. So in this case, I'm going to say new component. We'll give the component a name. We'll call it hub. We'll then define the view that we're looking at. And then from here, we just select the geometry that's associated to that view. Lastly, we can define a base point. And in my case, I'm just going to make sure that I get the midpoint there. And as I do that, it creates the hub in the list, and it also creates the view. Now, in this case, I do have the front view kind of started, obviously not finished, but I can come in here and create a new component view, give it a name, and then select the geometry, and then to define the position of it. And so the idea behind this, again, is that I can create as many views for a specific object as I need, and I can store them within a file. Now, in this case, I am going to make this a little bit bigger. I don't know why it loads so small out of the box, but I'm just going to move that a little bit so I can see more. So what I want to do, now that I have that part essentially created, I'm going to save the changes, and I want to bring this hub into my other design. So I'm going to go over to my gear pump assembly, and I've developed that part to be used against this shaft. So in this case, I'm simply going to find that file, select the hub, grab the view that I want, and then drag and drop it into the model. And as I do that, I can then position it and place it into position. I'm not exactly sure why this one missed some objects. So I'm going to go to Edit Objects, and I'm going to tell it to add, and I'm going to tell it to add those two entities. And when I hit enter there, why were they filtered out though? Is it because they were hidden? Doesn't make any sense. Interesting. I'm going to do one more thing here. I'm going to take these and just do a power edit on them. Oh. M12, yep, finish. All right, what's going on here? Edit, select by object. Next, normal. Okay, so power edit one more time. M12, next, normal, finish. Side view now has all of it. Okay, cool. So that in turn fixed that data. I'm not sure why the, something to do with the hidden line generation. Last time I did this, I didn't actually make them hidden inside the model. But now that I have that, we have in here the two holes as defined inside of that hub. And so now that I've done that, I'll save the changes. And when I go back over to the other model, we'll see in here that the external references have changed. And as I reload them, those will in turn pop in. So we can generate that. We can generate that data essentially as needed. And if I need to make changes to these components, the references are still defined and stored. And so we can see in here that that hub is now part of the main structure, but it's not part of that gear pump subassembly's BOM data. And the idea behind this is that I can reorganize this information as required. So say, for example, this hub was supposed to be part of that subassembly. All I have to do is drag and drop it into position, and then it buries itself into that substructure. Now that I've done that, I want to take a look at the bill of material data on this design. And at this point, I'm done with the structure catalog, so I'm going to dismiss that. Within the structure catalog, within the BOM data, I want to generate this table and make sure that it's up to date for my data set. So to update this, I'm just going to right click on it and go into Power Edit. And then in here, we can see all the objects as defined. In my case, I want to make sure that extra data has been added and the hub is not showing up, even though it's part of it. Let's go to, let's close that a second and go over to Annotate. Edit the part references. Why is it filtering that result? It's not set to exclude, and it's part of the main subassembly. Interesting. All right, let's do this. Let's take a look at this. At the parts list. I'm not sure why my part's not showing up. Something is definitely not set properly. And I know I have the BOM in that part. Let's jump back over here a second and make sure. Yeah, I don't know. That's super weird. All the data looks fine. I'm not sure why it didn't add that to my bill of materials. It's inside the assembly, so that's where we want it to be. All right, I don't know why. Adding it to the subassembly somehow messed it up. I'm not sure why it did, but as soon as what I was expecting to happen was this, right? As soon as I insert that component into this design, the bill of materials and the parts lists associated to it immediately update. So we can see in here, once I shuffled that to a new position, it immediately added the hub to the BOM, and I didn't have to change anything realistically, it shouldn't have to change anything in order for that to happen, right? Anytime I use the browser to define this data, as far as the content browser is concerned, it will bring that data in to the bills of materials that already exist. Okay. And again, I always have access to that hub and the side view and even the holes that are defined within it. And I can generate, substructure within the drawing views and create them as necessary. I'm going to jump over to a different data set that kind of shows some additional just annotative functionality here. So the first one is that I do have a set of assembly parts that I've brought in. And in this case, you can see there is no actual mechanical data or no structure data. So I'm just going to go back to standard mechanical here and just turn those tools off. And what I want to do is I want to make sure that the components that are hidden are hidden. And if we take a look at this upper view here, we can see that these two sprocket sets, this one and that one, are actually behind a number of these other parts. So what I want to do is just create a hide situation to make sure that it's correctly referencing them. So in this case, we can see this plate is that plate, and it's in front of the mounting plate here, and then those sprockets are even behind that. So in this case, I'm going to hit the hide situation tool. I first select the foreground most objects, and then I'll hit enter, and it will bring up the hide situation dialog. And the idea behind this is that I can create new levels, move those levels inside the structure. So in this case, I'm going to grab level 3 and move it down. And then in level 3, I'm going to specify the sprockets are in that level. And the idea behind this is pretty straightforward. The really neat part of this is that if I were to go in and say do like a rotation command and maybe rotate the plate structure about that center and change its position, the hide automatically updates. And we can see that effect immediately. Now, in my case, I did miss a component, so I'll undo that. And there was that bolt there that's part of that structure that didn't get rotated with the rest. But again, the structure in here doesn't matter, right? As long as these components, as long as I don't, explode this view, for example, that hide situation pays attention to the true foreground background data, and it automatically adjusts it. More importantly, it doesn't damage the objects in the process, right? So even though this is, essentially broken up into several different entity types, it knows not to, make it separate objects. It's just doing the hide situation on its own in the background. So some other things that I can do inside the space. I've got a number of holes over here, and I want to just quickly generate a hole table for these holes. One thing to note is I did use the content data for the through and blind holes as required in here to generate those views. They're not just circles. But now that I have that, I can come in and get a hole chart from this data set. So the first thing I need to do is define where the origin of my XY coordinates are. So in this case, I'm just going to extend off these two edges here to get to that hard corner. Set my rotation angle as 0, and then it defines my X and Y coordinates. I'll give that a name. I'm just going to use the default of 1. And then from here, I just need to select the holes that I'm interested in. Now that I have those selected, I can hit enter, and it generates the table. It also goes through and automatically marks all of the hole notations as required. Now, this is style driven, so I could go in here and change things like, say, for example, I wanted to stack, make sure it's organized by, we'll say we want to organize them by type of hole instead of just their position from X, which is what they're doing right now, right? It's going from closest to farthest. If I wanted to organize it by hole type, I just have to go in and edit the hole style. So if I go into the power edit, I can come in here and specify different ways to filter and organize this data. I can also remove them if I missed ones. I can also do things like change how the hole table is defined. If I go into settings here, we have a whole slew of different options for, how they're defined, the orientation of them, and so on. So we really get some nice options in here. Now there is one other thing to note. If I had holes that were not holes, it does keep them in the list, and it will just mark them that you've selected geometry that's not a hole object inside of AutoCAD Mechanical. Okay. The other thing that I can do as well is at any time, if I use my content generation, one of our options in here, oops, let's get that back to full size there. There we go. One of our options to generate component data is to generate things like shaft components and various types of shaft components. In my case, I've got some sprockets in here, and these sprockets are actually power objects. So in this case, we're dealing with roller chain objects. I can specify what type of chain it is, and then specify the sprocket data. And in my case, I actually shrank this way down, or actually updated its position. Let me grab that and move it back. Move. And because I modified that component, I need to go back into my hide situation, and I can move it to a new position, and that would in turn update it. But the other big thing that we have available to us is anytime I run, say, like a bolted connection tool or that screw connection tool, I'll go into my screw connection, specify the type of fastener that I want. We'll grab a hex bolt. Not sure why this isn't expanding. Come on. There's a lot of data. I don't have any filters turned on right now, so we're getting the full gambit of all of the data. So it can take a little bit of time to load. In this case, I want a regular hex bolt. Specify the size that I want. I can add the washers. So we'll just put a plain washer on this. And then on the bottom side, I want another washer. I need a hole in this case, right? If we take a look, these parts do not have a hole in place. So all I need to do in this case is define the types of holes that I want. Through cylindrical, we'll say that it's a close fit. This is another through cylindrical, because we do have two parts that we're interacting with. And then again, I can put the hex nuts on them as required. The other nice thing is that it is filtering these results down based on that first selection. So I'm not able to, grab objects in here that don't make sense, right? It won't let me put a metric threaded nut on an inch threaded fastener. Okay? So I'll specify the size that I want. I'll hit next, define the position of this component. Let's go like that. Actually goofed that up. Let me go back a step and go back forward again. I didn't realize it wanted me to. I should have read my command line. So the first hole is from here to here. The second one is from here. Is from here to here. There we go. So now we've got our two parts defined. I'll hit next, define how I want it to generate the geometry, and then finish. And it generates that geometry. Now in my case, it created one that was really, really large. I'm going to go in and erase this out. And I should have one already stored. I forgot that this is a metric data set. If I come in here and go into my power edit, this one should already have the data inside of it. Power edit. What's going on there? I'm not sure why that didn't come up. just grab this one and edit it. There we go. So we can see in here I've got my M10 fastener set. And again, if I wanted to add, say, another nut to the bottom side, I can do so. So we'll put a cap nut. And then in this case, we're dealing with ISO. So let's go find our ISO threads. Additionally, there are ways that I can filter these results. The first big way and easiest way is to turn off the fasteners you're not using. Additionally, these databases, they are completely editable. So I just have to go in and specify which ones I want. So I can add that nut there, M10. And when I hit finish here, we'll see it will redrive the data down and then add that nut on. In this case, that fastener might not be long enough. I can go into the power edit mode again and lengthen it. Some other things that I can do in here, I've got caterpillars for my weld annotations. If I go to my annotate side, we have our welding tools, and I can generate various welding symbols. I'm not sure why the library is not loading. What's happening here? I'm not sure why my weld tables aren't loading. I'll just edit the one that exists. And as I edit this, I can just specify things like the leg width, and then specify objects that I want to place it on, and then where I want the welds to go. So in this case, it was originally running the full length. So if I wanted to pull this in a bit from the corners, I can specify 2 positions for the starting and ending. Why did that break my weld note? It made it, but it's super, super tiny on top of that. Something's broken in my file. I may have to restart this document to fix this. Let me edit this one more time. But the idea behind the welding notation is instead of having to draw an arc and pattern it, for example, to try to represent those objects, we have a tool specifically built for these object types. So I can specify the leg width. I'll select the line that I want to place it on. I'll tell it to create the entire object. Yeah, it's doing really weird stuff. I apologize. The last piece of this that I wanted to kind of show is we have the ability to create one structural steel shapes, but we can also do essentially different calculations within the system. So if, for example, I wanted to run a calculation on, say, a fastener stack, for example, I can run a calculation to say, is this screw calculation or is this fastener set going to function? Let me grab one. What in the world? Let me close this and open up a different one. I don't know why this file is freaking out, but we'll switch files. There we go. So as I select the fastener and run the calculation, the idea behind this is that I can specify all the data regarding each of the pieces of the analysis, the plate material that it's going to be dealing with, the definition of the engagement, the overall loads applied to this component. And then once I have all this information defined, I can then jump over and see the result information regarding the shearing of that component, what types of overall shear stress I'm going to get, information regarding the, how well the plates are going to be sealed. And then lastly, I can define a text output file, and I can define this and place it on the model. So in this case, I'm just going to create another calculation for that analysis. So we do have the ability to do that screw calc right inside of AutoCAD Mechanical based on not only the data that we've defined during the creation of the geometry, but then giving it the last little bits of info as required. One other really powerful tool is the detail view. controller. And what the detail view does is honestly one of the more interesting aspects of the software. But when I go to the detail view command, I specify either an object or a circle that I want to work with. And so like in this case, we'll come over to, let's do this interaction here in this corner. So I'm going to draw the circle where I want the detail view to land. Once I have that, I can select the detail view command, select the center of the circle, or select the object. And then from here, I can specify the change in scale, which in this case, I want it to double the current scale, give it an identifier, define the label for it. When I hit OK, I can then place that on the drawing. And as I place that, it generates all of the detail. If I wanted to create a connection line between the two, all I have to do is just click locations to define where the connection line is. But in this case, I'm just going to hit enter, and it will generate the detail view. Now, the real power of this is if I go to my power dimensioning command, for example, and I dimension things like maybe I want to dimension this thickness. When I dimension it inside of this view, it gives me the correct value, the 5.5 millimeter gap. And obviously I have the full, controllers there. And just to show here, I'm just going to run a quick distance measurement from point to point, and it is 5.5, right? But if I go to that other area and I run the same power dimension command and I select that same object, the dimension still comes out as the right value. Now, in order to do this sort of behavior inside of AutoCAD Core, you would have to do all sorts of really weird steps. Additionally, if objects disappear from in this space or if they move or change, this view will automatically adjust. So say, for example, I do a stretch. I'm going to zoom out a little bit here, and I move that position. I can select this and tell it to update. Where's the update? Why did you not update right away? Let me do this one more time. Pyro Recall. Select the object that I want to recall. Select the center of the circle. Much rustier at this than I thought it was going to be. Center. It's making a new one. I don't want to make a new one. I want to edit the one that already exists. There it goes. I don't know why I didn't do that the first time. But once you have a detail view defined, if you go into AM Power Edit, you can select that detail ring, and then it will redefine the geometry. And the idea is it was also giving me the chance to potentially like add the note or the connection line at that point. Some other things, obviously in this case, that detail ring will auto move around. It's always the text is attached to the ring itself. So as I grab that and move it, it'll just stay in position around the ring. And the general idea behind this though is that this is a lot of really complicated steps in vanilla AutoCAD or in AutoCAD Core, and we're just trying to avoid that. within the space. So again, there are all sorts of other commands we didn't really delve into. Obviously I talked about the bill of materials, but we have the ability to create a parts list from that bill of materials within the space. We have the same ballooning tools that we have within the AutoCAD core, with some additional functionality as far as pulling actual balloon data. So it's a multi-liter object, but it's intelligent to the BOM data underneath. Similarly, when we create power dimensions, we have a whole slew of other tools for doing things like ordinate dimensioning, arranging the objects as necessary. In the drawing tool set, we talked about, some of the drawing tools, but things like hatch patterns, right? One of the big things with hatch patterns is we don't want to have to keep redefining it the same way every time. So we can store those hatch angles and types and the spacings within the hatch pattern. When I draw objects, we can specify it to automatically filter my object snaps. And the object snap settings are a little bit different within AutoCAD Mechanical. If I go down to, cancel that, it's in options. AM drawing. Automatic center lines. Where is my preferences? Snap defaults. So within here, we can specify things like what types of snaps we want to use. And then we also have filter options. So this is actually a functionality they added to AutoCAD Core not too long ago. I think it was maybe last version of AutoCAD, the vanilla AutoCAD or the AutoCAD Core, where it won't snap to geometry on a dimension, right? AutoCAD Mechanical has had that functionality for ages. Same sort of thing with hatch patterns, right? If I have a hatch pattern in place, it will not, the object snaps will completely ignore the hatch patterns. It won't try to snap the geometry inside of them at all. So we just have that ability inside of this space. So I definitely recommend users, get in here and dabble with the AutoCAD Mechanical tool set. The drawing tools are phenomenally faster than trying to draw things by hand using the manual drawing creation methods. Especially if you're doing a lot of, view creation or 2D view creation, the construction lines can be immensely helpful. And then obviously the content center, as far as the, being able to place holes specifically based on, fastener sizing, and have it generate the views and be accessible and editable after the fact. All of that is just really powerful functionality. So at this point, I'm going to take a look at some of the questions that have come up. I don't see any actual questions pertaining to AutoCAD Mechanical. Just some looks like some sound issues that we had in the very beginning. Let's see if there's anything I'm missing here. Nope. Is there any questions regarding the AutoCAD Mechanical toolset before we wrap it up? Well, I thank you for your time today. As Ashley mentioned, there will be a survey as well as a link to the recording. Ashley, do you have anything else to add?
I don't. If you think of additional questions, you can simply reply to that GoToWebinar email, and we can get those to Keith or whoever to get your questions answered. We will have that survey pop up as we close down today. We ask that you take a few moments to fill that out. Keith, it does look like there might be a question in there now. I don't know if you want to cover it.
Yeah, so as far as, third-party software is concerned, dealing with Inventor, ProEngineer, or step files, we can definitely open and import those files. We have inside of the software, and a lot of this is in the AutoCAD core, but we just go to import. And then from here, we can see the list of the different types of files that we can open. So, the standard formats, STEP, IGES, and SATs are in this list. We can open up Inventor parts and assemblies. We can also open up Pro Engineer, SolidWorks, Solid Edge, CATIA, JTNX files, pretty much the full gambit of our, the most commonly used third-party, or the most commonly used formats within the system. The big thing about that, obviously being able to import that data in here, is it is a 3D file most often. So you may want to consider using things like the flat shot command or the flatten tool within the express commands in order to turn it into a 2D profile that you can then work against. However, the big thing to think about there more than anything else is just, we're dealing with 2D drawing tool sets, not necessarily a 3D drawing tool set as far as these commands are concerned. If you were trying to import it to then turn it into like an AutoCAD file, obviously we can do that as well. So yeah, absolutely, we do have access to importing files.
Okay, well, I don't see anything else, so that will conclude it for today. Thanks for attending the webcast, everyone, and have a great day.
Thanks, everyone.